Hello, class. We're going to do our final review here today. Just want to thank you all for the hard work you put in. I know being online for many of you is not at all fun, as it's not for us as professors either, but I'm thankful that you've been patient with me. My computer skills are not as advanced as many, but you've been very patient and I appreciate that. I know you didn't sign up for this as well, so hopefully we can get through it together. I will be emailing each class when their final is. Some of those times have been adjusted slightly. That was given out about a month ago or so. And rather than putting them both down here and confusing you, I will email you separately on whatever section you happen to be in when your final will be. Again, you have to take that final during that time slot. So you'll also be able to tell it when it says in your content of your Blackboard, it'll tell you when that final exam will be available or accessible for you. That's also the beginning of that exam period, if you will. Exam itself, I don't think is that terribly long. I shortened it some from previous exams. It's only 17 questions. 14 will be multiple choice. And those will be worth 5 points each, so that's 70 points there. You'll have only 3 hypothesis tests to do. Each are worth 10 points. That makes 30 plus 70 gives you the 100 points for the final exam. I really want to stress probably the most is that the majority of the test will come from chapters 6, 7, 8, and 9. Those chapters will have the majority of the questions coming from them. I also want to emphasize that every question will be covered somewhere in this review, but not every point in this review has got a question about it. Again, that's due to the time frame. Otherwise, I would probably have 100 questions and you'd never get done. So to get it down to 17, I had to pick and choose which ones, but we're covering all the concepts, all right? But again, chapters 6 through 9, those are where majority of the questions will be coming from. First of all, chapters 1 through 5, just to review some of the main concepts. 2 main types of statistics that's been broken down into 2 categories. Descriptive statistics, which where we describe data. We show central tendencies, graphs, charts, etc. Inferentials, where I take a sample and I try to predict something for the entire population. We should be able to know and match up either one of these to whatever the situation would call for. There's 2 main types of data. Quantitative data, which is naturally numerical. Qualitative, which would not naturally be numerical. Those are some key concepts early on. We had a lot of different types of graphs or charts: dot plot, pie chart, histogram, bar graph, frequency distribution, stem and leaf. We should also know what types of data, qualitative or quantitative, is the dot plot suited for. What types of data, qualitative or quantitative, is the pie graph suited for, etc. In case you didn't know that, here's again a repeat of that. You can freeze this video if you want, but make sure that you know what each one of those fits to. We had measures of central tendencies and variations. Should have central tendencies and variations. Central tendencies would be like mean, median, and mode. Variation is described by the standard deviation and the range. And we should know how to find any one of these with our calculator and also interpret what they mean. We should also know where the mean, median, and mode lie on a normal distribution, how the standard deviation fits into that play. That has to do with the empirical rule. And we also should know if the mean, median, and mode are not equal, how that affects the overall shape of the distribution. That should be in your notes. The empirical rule, these are approximations. We got the exact values off the chart. And those charts, you can have your textbook with all the charts available to you. Those will be needed on the test. So if you don't have a textbook, make very certain that you get those charts copied off because you'll have to be able to use those charts. Anticipate getting a set of data, asking to be found the mean, median, mode, range, standard deviation. You should be able to do that on your calculator. In case you want to double check, here are the answers for that. You should be able to come up with all of these numbers with that set of data, right? If you have to freeze your video and double check that work, that's fine. But I'm going to move on here now for time's sake. We should be able to find what percent, if I give you different scores off of a normal distribution. I'll promise you there'll be somewhere I'm going to ask you for the percentage or the probability where I give you the scores. But you also should be able to go the other way, where if I give you a percentage, you can come up with the score. In this case, the height. Here's a tolerance of heights. Here's a height. These are where I give you the percentages. You would have to then determine the actual scores that pertain to those. The z-score, it's your individual score minus the mean divided by the standard deviation. Your z-score describes the number of standard deviations that this x-score is from the middle, as well as the direction. Positive z-score on the right, negative on the left. We've seen all that before, that's why this is a review. But these would be z-scores. 1 standard deviation to the right, 2 to the right, 3 to the right, 1 to the left, 2 to the left, 3 to the left. Pretty straightforward stuff, I hope, for all of you. Some probability rules, some general one. Any probability is going to be between 0 and 1. The closer it is to 0, the more unlikely. The closer it is to 1, the more likely. To get that probability of an event, we find the number of ways the event can occur divided by the total. We also had the additive rule in statistics, probability of A or B, probability of A plus probability of minus probability of both. We've seen that before, we've used it before. We should be able to find simple probabilities, unions, intersections, the additive rule which I just put down. We have conditional probability. We have run the test for independence. We should be able to apply any of those to contingency tables as well. I'm going to tell you right now, there'll be 3 or 4 problems pertaining right out of here. You have to know this stuff, especially as it pertains to a contingency table. So make sure you're prepared for that. Again, if you have to freeze your video to take a second look or a picture of that, do so, but be ready to do any of those. I'll go right to here. Here's an example that all of you should be extremely good at. Probability of a low risk, I'm going to take the total low 16 over 40. The probability of high risk, and that means they have to be in both, got to be in high risk and it's got to be in food retail. Well, the ones in high risk and food retail are these 15. The probability of that 15 would be 15 out of 40. Low risk given its aerospace means it's got to be some of these 15. The probability that it's low given it's part of the 15 is 6 out of 15. This is the one that everybody misses, high risk or means it must be in at least one. It's got to be in it. This one or both. high risk or food retail. High risk are these two, food retail are these two. That means these three, the 10, 9, and 15 over 40 is what that would be. The answers to that, this is over 40. This didn't get printed here. But again, we should know these just inside out. They should be automatic for us. This is the one that everybody seems to miss. Okay? We also were asked if it's low risk, or excuse me, is being low risk independent of whether it's aerospace. What we do is we would test the probability of it being low risk, and we're looking to see is it equal to the probability of it being low risk given its aerospace. That's one way to test it. Or I could test it, probability of it being aerospace. Does that equal the probability of it being aerospace given its low risk? I need to check to see if they're equal. If it's equal, we know that they are, in fact, independent. If they're not equal, they are dependent. If these two are equal, these two will be equal. They might be different numbers, like this might be 3 equals 3, this would be 5 equals 5, that's immaterial. If these are equal though, then you know these will be equal. That's why you only got to test one of those. All right. I'm pretty sure this one is unequal, but let's just double check here. Low risk given aerospace, we just found that. Low risk given aerospace was 16/15. Probability of being low was 16 over 40. These two are not going to be the same, I don't believe. I'm pretty certain I can't do it mentally right now. But this would be 4/10. This would be 2/5. Actually, they are equal. Sorry, did not see that. They are equal, and consequently, they would be independent. They would be independent. We had expected value, if you remember. Expected value is where I sum up each x times the probability of x. Applying that formula, again, if you have to freeze this to copy it down, but you should have it in your notes. To find the expected value, it'd be 0 times 0.18 plus 1 times 0.39 plus 2 times 0.24, etc. That would be an expected value. Starting chapters 6 and 7, we have the normal distribution table. Again, you will definitely need that table, and you need to either have copies of it or have your book with it available to it. But you're going to have to be able to find probability and find a score, as I've already emphasized to you on that. Here's just a check. All of these, I'm asking you to find a probability. I've given you a normal distribution with the mean and the standard deviation. The answers to all of these are right here if you wanted to check your work. So again, if you want to freeze this video, freeze it. Take a picture of this, make sure that you can come up with all of these individual probabilities. As an example we did where we had to find a score. We had to find the interval of income level that would be given the aid. This is where I've given you the percentage right here at 15%. You got to find the actual score, or the actual value. Those are examples of what I mean by finding probabilities and scores. We had the central limit theorem. That, of course, meant we were working with sample averages, That's what the central limit theorem does. It has some very unique theory and power to it. We should know what those are. We should know, for example, that the mean from the sample, mean of all the samples together would be approximately equal to the mean of the population. The standard deviation is the population standard deviation divided by the square root of n. This is the one we use when I have sample means and I want to find sample z-scores. That's all about the central limit theorem. We should know its restrictions. For means, you have to have 30 or more in your sample. For the probability, it has to have n times p greater than or equal to 5. Hopefully that sounds familiar to you. Here's an example. Again, you can practice this one on your own, but the probability of a sample of 64, find the probability that it's got a mean weight more than 106, x bar greater than 106. And to change it to a z-score, remember that's a different formula there. That formula is x bar minus the mean. Notice this, it's s over the square root of n. That should give you a 2, which gives you the probability. Mean weight of 112 should be greater than 112. Again, I changed it to a z-score and got 4. That would be using this formula right here. Okay? The mean was 100. That would be my mu in here. Well, we should be able to do that. Here's an example of keeping 2 straight. This one is the probability that an average length, and that's why I have x bar, very similar to the previous example. My z would be x bar minus mu s over the square root of n. Here, I have the probability of a selected piece. That's an individual piece. That's why it's x here rather than x bar. For that one, my z-score is x, not x bar, minus mu divided by the standard deviation, s in this case. Distinct difference there. We have to be able to recognize those in the problem. Mean length, average length is a key phrase. Individual piece or individual score is a key phrase here. But again, we should be able, all the numbers appear to be the same. I just describe them with different nouns. That changes your problem. Chapter 8, we began with confidence intervals. We should know what affects its size, making it a wider or narrower confidence interval. We should be able to construct them with z's, large sample, with t's, small sample. Again, nobody's going to scream at you which one it is, but be ready and read your problem carefully to know, am I using a z or am I using a t? The general template, you've seen this before. Sometimes it's a z, sometimes it's a t. It's a point estimate from your sample. This adjusted standard deviation is different, whether it's proportions or population means or whatever. But we should be able to find some as well as interpret. You can anticipate where I'm going to ask you to find some and also where I'm going to ask you to interpret them. Large confidence interval for mean, got x bar, and I have this adjusted standard deviation. I use a z. Small sample, we use a t-score here. We had n-1 degrees of freedom. We had to be able to use that t-chart. Proportions, we only looked at them for large ones here. Want to remind you again, sometimes you're going to use the p and q from the sample because you don't have a population one to go back on. Sometimes you do have a population one to go back on. So know which one to be using in either case. But again, both of them involve a z. It's just a matter of what do you substitute in for. Okay? As I mentioned, most of the questions come from chapters 6 through 9. 10 through 12, I believe I've only got 2 questions. These are all rather unique situations where we use that concept of hypothesis testing. So there'll be 2 questions out of here, but you don't know there's more material than just 2 questions. We had 2 populations, if you remember. We looked at some difference between means and difference between proportions. They were differences. We also looked at multiple populations where I used an F statistic. That was for means. We also looked at multiple levels of variable for chi-square. We had a one-way and we had a two-way ANOVA test for chi-square. Again, that's hopefully fairly recent, which is why I'm not going to spend a lot of time on that review. Finally, you will be allowed an 8x11 sheet of paper with notes or formulas or anything you want. And you can obviously will need your calculators. So you have a cheat sheet, you need your calculators, you need all the charts that we had out of the text. All right, so make sure that you have that, and you're going to need your phone to take a picture when you're done. I'd like you to take some blank sheets of paper along, like we've done in the past, and your phone. Put your answers on a blank sheet of paper, take a picture and put it in the corresponding Dropbox. So it'll be done very similar to what we've done in the past. Again, I'll be sending out each section when your particular final is. And again, thank you for your hard work, even through all this COVID-19 adjustments. I'm very proud of what you've all done. We will see you on your test.